So that's really helpful. As you can see, we have a pole. I'm not sure if you can tell, but it's very high up, and our field worker can stay safely on the ground and look at that pole, take some pictures of it, and then take it back to our office and work safely on it there. And we also do quite a bit of marketing. Internally, it is for, we mainly use it for bid proposals and things like that, but we also will go to client sites and take pictures of their buildings, construction sites, anything they want, a new roadway, you name it, we've got it. So it's pretty straightforward. And that's what we do at SSR. Our team consists of 4 people. So we have Ian Engstrom. He is the Memphis Director of Operations, so he is in charge of all of us. He's been at SSR for 8 years. Then you have me. I'm a GIS analyst, as I said, and I'm also FAA Part 107 certified. And I've been with SSR for a year, so I will go out and I will either fly the drone, I can do the post-processing, things like that. We have Tyler Boone. He is a transportation engineer at SSR. He has been here for 9 years, and he is also Part 107 certified. So Tyler and I are both the drone pilots. Tyler will also, not only fly the drone, but he will actually go out and survey our ground control points, which I will get into a little bit later. Chris Fortune is our CEI technician. He has been with SSR for 39 years, so that's a long time. He goes out and he will survey our ground control points. He'll put them down for us and survey them.
Excuse me, I'm just going to interrupt for just a second here because I just want to get some feedback. Is everybody, could let me know if anybody's not able to hear the presentation? You can send it through the chat, or if you're, I just want to make sure this is working for everybody. I guess the other issue is that I want to make, I'm trying to admit people to the meeting and make sure that y'all are still seeing the presentation. So hopefully you're not seeing the Zoom controls while the presentation's going on. So everything good? All right, great. I'm going to go ahead and start this again and pick up where we left off.
So let's get into surveying with accuracy. The main thing that you have to start with is flight planning. If you get your flight planning wrong, you will not get a good model. So the first things first, you have your site. You have to make sure that you're actually able to fly that site. So there could be a lot of tree cover, which is not great for drones, or a huge area of water. Drones don't like that either. So any uniform surfaces, like if you have a bunch of sand, drones don't like that. So the speed, height, and overlap of the drone matters tremendously. So this is based off of our Phantom 3 Pro standard operation procedures. So we fly less than 5 miles per hour. We fly at 100 feet or less. And we have at least 80% forward overlap and sideways overlap. So basically, what that means is that when the drone is flying, the flight path has to overlap itself 80%. So basically, each image is overlapped 80% by another image or images. That way you get great, coverage for your area, and you make sure that you're not missing anything. So it builds a better model. So for our drone calibration and camera setup, after we do our flight path planning, we use DJI Go and DJI Go 4. So we use the DJI Go 4 app for our new Phantom 4 Pro version 2. So that's just for setting up the drone. So it's basically calibrating the drone, the IMU, the compass. You need to calibrate your compass and IMU every single time. Make sure the drone knows where it is. Make sure nothing's interfering with the system of the drone so it'll run correctly. And basically set up, your camera, if it's sunny or cloudy outside, and what type of file you want to fly with. So we always take our images with raw files because they're bigger and can hold more information. And then later on, we convert them to TIFF files, which I'll explain later. And then the autonomous flight app that we use is Maps Made Easy. It's the business version. The main reason we use this is for its terrain awareness feature, which is absolutely amazing. So the terrain awareness feature uses the shuttle radar topography mission data from USGS. So what this does is it loads in the elevation of the site. Basically, this is older data, but it allows the drone to know exactly where the ground is. So in order for you to get consistent imagery, you have to fly at the same height the entire flight. So if you take off and you want to fly at 100 feet, if there is a 100-foot elevation change upwards, the drone will probably run into whatever it is, whether it's a hill or whatnot. So same thing if there's a dip. If you have a 50-foot decrease in land or in elevation on land, instead of flying 100 feet above that, it's actually going to be flying 150 feet above that decrease. So basically, what terrain awareness does is it tells the drone where the ground is, and the drone will automatically go up and down in altitude based on the ground. So it'll always stay 100 feet above the ground, or however high you want to fly. So if we didn't use terrain awareness, we would actually have to have separate flights for each elevation change. So if we had a site that had part of it start at 100 feet, we would have to fly that 100 feet. And then if it had another part of it that was 200 feet, we would have to start another flight at that 200 feet because it has to know exactly where the ground is. Which gets us into why we fly so slow. With the camera specs we have now with the Phantom 3 Pro, it has a rolling shutter. So basically, when the drone is flying, it's taking a picture, but it's not taking the picture all at once. It takes it over a few seconds, so it's called a rolling shutter. It usually has a higher pixel count, and it's really good for stationary or slow-moving objects, but obviously, our drone is not stationary, so we choose to make it a slow-moving object because it's easier and it takes better imagery. So if you look at this diagram or figure, you can see the rolling shutter where the fan has had a picture taken of it, and the fan is warped. It's not an actual picture of the fan. So that's what a rolling shutter does. The Phantom 3 Pro also has 12.76 megapixels, which is an okay resolution, but it's not fantastic. So we just upgraded to the Phantom 4 Pro version 2, which is super fantastic because it has a global shutter, which means that it takes the image all at once. It doesn't wait to take it. Just once it takes it, and that's it. It's also got 20 megapixels, which is way better. It's got way better resolution, which will give us way better models that we have. Our models aren't bad now, but it just gives it a better resolution. So for our post-processing, we've got quite a bit of software involved. So as I mentioned earlier, we collect our imagery in raw files, so DGN. Drone2Map actually doesn't take the raw files. We have to convert it to TIFF or JPEG. TIFF has better resolution, so we typically use that. So in order to have the image conversion, we use Lightroom Classic, which basically allows us to change the imagery into TIFF files, but it keeps the geolocation, the metadata, all of that, so we don't lose any of our information. And our post-processing software is Drone2Map. So it has different project templates, so it's got 2D rapid, 2D full, 3D mapping, and inspection. So basically what 2D rapid is it's just you throwing your imagery in there and running it and making sure that your report is good. So your post-processing report is okay. It's telling you your model's okay. We mainly use the 2D full. So it looks at everything. When it processes the imagery, it matches up the automatic tie points. The Rapid does that too, but basically there are points in each image that match up with other images. We also use geometry verified matching, which is super big. So if you have a road, a truck, or a building, it knows to match the geometry of those photos. So if you have a truck in one photo and it's the same truck, it'll match the geometry of that truck. It doesn't have to be a truck. I said it could be a road or, just any feature. It matches the geometry of that. So it's not just saying, hey, these pixels kind of look the same. It's actually matching geometry. So Drone to Map actually uses the processing image of Pix4D, which right now is the best drone processing software out there. It gives you a lot of flexibility and you're able to edit more, but Drone to Map's a little bit more simple. It allows you to have the same result as Pix4D, but it's not as, you can't manipulate it as much. So it's pretty user-friendly, so that's good. So as I mentioned before, we have ground control points. This is important for flight planning and for post-processing. The way these work is, if you look here, we have Aerotoss, the survey markers. So it's a checkerboard pattern, and I think it's 45 inches by 45 inches. I can't remember the exact size at this moment. But basically, what we do when we flight plan is we will look at our site, see how big it is, and determine how many ground control points we need. So some sites require like 5 or 6. Other sites require 30, or a lot of ground control points. So basically what these do is you take them out and you put them in your site. They need to be evenly spaced throughout your site, so about 500 feet apart from each other. And Chris and Tyler will actually go out and survey these points. So it tells you the exact elevation of those points. So basically what these do in post-processing is you have your data file with all of your ground control points in it, and you said, it shows you each elevation, the exact elevation of where this is. And so you put it into Drone to Map with the exact same coordinate system, and it tells the imagery, hey, I'm actually at this elevation. So don't think I'm 50 feet above where I am. I'm actually at this elevation. So basically it lays a framework for all of the images. So if the drone says it was actually taken at 130 feet in the air and it thinks that the elevation is actually 200 feet on the ground, the ground control point says, hey, I'm actually 150 feet. So don't think I'm 200. And so it lays that framework out. So when you're actually linking the ground control points in Drone to Map, you actually have to have an even number. So what I mean by that is when you have your ground control point, you have these images listed here on the left. So DJI 0272, and all of these images listed here. Basically what you'll do is you'll go through each image for this ground control point, and you will mark the exact center of the ground control point, which is why it's great to have ground control points with contrasting color. I would not recommend white and black checkerboards if you decide to do ground control points, because the white is actually too reflective. So if you look over here to the right, the little yellow X in the middle is a little bit small to see, but that is marking the exact center of that ground control point. So once all of them are done, you need to make sure that you have an even amount. So if you have an odd amount, it actually throws off the model. So each side. So if you have a ground control point, you want to make sure that you're marking it in the center of the image. So if you have an image where it's skewed off to the side and it doesn't really show the ground control point, that's actually going to throw your model off. You want to have it nadir or right above it. If you can't, you want to make sure that you have an equal amount on each side. So if you have an image of it and it's kind of to the left, you want to make sure that you have an image of it kind of to the right, so it kind of evens each point out. Which gets us into our post-processing report. This basically tells us exactly what's going on with our model. It tells us if our images were calibrated, our data set, our camera optimization, the matching that occurred, and the most important part is the georeferencing. So this tells you the accuracy of your model. So this one right here, I think, is a little less than an inch, so plus or minus an inch. And this basically tells you if your model's good or not. So if we run a model and it tells us we're 3 feet off, if we followed all of these steps, it probably means someone marked a ground control point incorrectly. And when I mean somebody, I mean I did it incorrectly. It was me. So I have to go back through all of the ground control points and make sure that they're all marked correctly. And it's typically not. It's typically I accidentally marked something incorrectly, or I accidentally clicked in the wrong area. But once you fix that and rerun the model, it shows up just fine. So some of our models that we have, you have different types of models. So our first one is our Orthomosaic. So this image on the right is not just one single picture. An orthomosaic is basically all of the images stitched together to scale. So you actually can measure true distances on it because it's an accurate representation of the Earth's surface. So if you look, it's got great detail. This smaller area is actually the same image, or the same orthomosaic, just blown up so you can see it in all the detail. And if you can look, there's actually a pool in this image, and all of the water is messed up because drones do not like water. And then we also have our digital surface models, which basically shows elevations at mean sea level of objects above the Earth. So it'll basically show you everything that's there. It'll show you trees, trucks, all types of machinery, buildings, everything. We typically don't use these mainly for what we do because we are always looking at the terrain, the contours, the elevation, and things like that. So mainly what we use is the digital terrain model. It's basically just the ground. It processes it, and then it just looks at the terrain, obviously, in the title. So it takes out all of the machinery, everything, and it averages it out. So in this larger image, you can see the digital terrain model of the new construction for I-69 in Union City. So the white is higher elevation, the red is a little bit lower, and the green is the lowest. So you can actually see the ramps and all the lines that the machinery has made. You can see the grading where it kind of looks choppy there on the left. That's where they haven't finished grading it. So it's very cool. You get to see all of that. You can actually see the little hole at the top right is a little drainage area that they made. So it's very detailed. It's fantastic. We were able to use this for dirt work quantities. So they had a subcontractor come in and actually move all this dirt. And so we flew the site before they started and after it was finished, and actually calculated the quantities of dirt that they moved. So cut and fill basically says how much dirt that they've taken away or added, and we were able to tell them how much they owed their subcontractor. In this little area, this little image down here is actually of a drainage area. So the red is higher elevation and it shows it sloping down into the white and green. So this is what we basically use for all of our engineers. for our sites. Engineers design off them. They're able to calculate the quantities, like I said, and basically be able to show what's going on with the Earth, which is super cool. So that's mainly what we do at SSR. We are more than happy to do other things like 3D models and things like that. But this is mainly what we do, is the digital terrain models. And then we're able to, change those into surfaces and use them in AutoCAD and things like that. So it's really cool. So now let's get to the questions. And if you need to contact either me or Tyler, you are more than welcome to do that. You can go to our website, and I think we will be sending out an email with our drone website information. So if you have any questions, feel free to reach out to us.
Oh, thank you, Michelle. That was a great presentation. Forgot to unmute myself there for a sec. And let's see, looks like there's a couple of questions in the chat. There was a question from Joe Armstrong. Are you able to see the chat?
I am.
About the FMV capabilities?
Yeah, so we do, but we.
Oh, I see. I see you actually already responded to another question in the chat, so you've been busy.
Okay, yeah, so we do have full motion video capabilities. We just don't use them. So we take we use the app. So basically it just takes photos every few seconds. I don't know the exact number at this time, but it changes based on the overlap that we use. Does that answer your question? So we do have the capability, we just don't use it at the moment.
And I saw that other question you already answered in the chat about SRTM instead of NED. I don't even know what those are. I don't know if it's beyond the scope of this presentation or not.
No, so that question was based off of the terrain awareness, the shuttle radar topography mission data. So the reason we use that is because it's built into Maps Made Easy. So instead of collecting the data and figuring it out before we go, we can actually just show up to the site and say use terrain awareness, and it pulls up that data for our flight area. So we're not getting more than we need. We just show up and fly, which is fantastic. Yes, we do. I don't know exactly which one we're using. So this is for do you use the GNSS systems for the ground control points? So we do. That is more for Tyler and Chris. I think our survey equipment is called TopCon. Does that answer your question?
Yes, thank you. I actually have another question. Have you ever experienced stitching issues with large areas or tackled any projects that are so big in scope or wide in area that you have stitching issues or have to do multiple days of flights and stitch those areas together?
Yeah, so that happens a lot with the larger areas. I know we flew the Dyersburg landfill, which was 92 acres. And we had a horrible time trying to fly it. The app kept messing up. All the metal in the ground was messing up the drone. So we have had stitching issues and have had to go back to a site and fly for about 4 days just to get it all fixed together. But it mainly depends on the site. For smaller sites or, for sites that don't have metal in the ground, they've been pretty easy. We do have a lot of issues near roadways or power lines. That'll mess up the signal of the drone. So we have the drone fly away quite a bit. So it's not it's not all easy. I know Tyler had to run down the street one day down, I think it was 51, trying to catch the drone because it just flew away.
Awesome, thank you.
So there's another question. What are the pros and cons of using real-time kinematic instead of ground control points? So the pros for real-time kinematic, you basically, honestly, I don't actually see the pros of RTK. I know that people say it's fantastic, but there is a huge chance that you could lose all of your data while you're flying. So if you lose connection, it doesn't have the information there. So if you come back after flying a site, but your drone had lost the RTK signal, it actually doesn't show the location of the images. So even if you do use RTK, you still need to have ground control points throughout your site, at least a few of them. It just makes the model more accurate. I would suggest using PPK instead of RTK. So PPK is post-processing kinematic, which basically it uses I don't remember exactly what it uses, but it allows you to keep that information in your drone, and you're allowed to go back through when you're post-processing to remove the incorrect data and the correct data and keep the correct data. But I personally don't like RTK drones. Does that answer your question? So this next question is, due to recent climate events, have you been called upon to support emergency medical services or emergency, oh my goodness, I don't remember what that stands for. I'm very sorry. EMS response or recovery operations. Yes, management, thank you. We have not so far. We might have an opportunity in the future to do disaster imagery after a disaster occurs, but as of right now, we do not have any contracts like that.
Hi, Michelle.
Hi, Dr. Kwan.
Can those drone models mount any other sensors, like sensors that including NIR or other kind of, hyperspectral sensors?
Right. So the DJI 4 and the Phantom 3, and the Phantom 4 can't switch out the payload. DJI does have a drone called the Matrice, and you can actually switch out the payloads for that one, but you can't actually switch them out for the Phantom 4 or the Phantom 3. I know that they did just come out with the Phantom 4 with multispectral imaging. Mm-hmm. So you could do NDVI and things like that with it. But as of, the drones that we use, we don't have that capability.
Okay, thank you. Glad to hear from here.
Thank you.
Michelle. Hi, Michelle.
Is that you, Miniature?
Yes, this is me. Great presentation. And one question. Does the weather have any effect on getting any kind of survey, like, rain, snow?
Yeah, so we cannot fly during rain or snow. It just doesn't work. If it starts raining, we have to stop immediately. If it starts snowing, we have to stop. It has to be a day where there is no weather interference.
Oh, okay, good. Thank you.
Yep.
Any other questions? Okay, it looks like our co-host has set up a poll for y'all to respond to. You might have seen in the chat. I actually can't access that because he and I are both logged in with the same account for some reason. But if we don't have any other questions, we'll go ahead and wrap this up. Again, Michelle, it was an awesome presentation. A lot of it went over my head because I don't have any training with drones yet. Hopefully, maybe someday, maybe my next career. But it was really interesting nevertheless. So again, thank you very much. It seemed like we had a great response here. Going forward, we're hoping to announce another webinar for October. Look for an announcement in the next probably next week, hopefully. And other than that, about time for us all to get back to work, huh? So thank you all for attending. Great seeing everybody, and we will look forward to seeing you next time. Thank you again, Michelle.
Yep, thank you all.
All right, we're signing off.